Good day learners. In this video, we are going to discuss about the basic feedback topologies. Let us understand and discuss about the four types of feedback topologies, which are going to be the voltage amplifiers, current amplifiers, transconductance amplifiers, and transresistance amplifiers. These voltage amplifiers are actually used to amplify the input signal and so that it gets the amplified at the output side too, which can be represented in Thevenin's equivalent circuit. Here, this input resistance is going to be very large compared to the source resistance, and the output resistance is going to be less than of the load resistance. In this voltage amplifier is actually suitable for the feedback topology called as series shunt or voltage series in other words. This current amplifier is actually used to amplify the input current signal and provide the current signal at the output side too. Here, when Ri, that is the input resistance, is going to be considered as 0, the source resistance is going to be very large compared to the input resistance. And at the output side, the load resistance is going to be very less compared to your output resistance. Hence, this topology is represented in equivalent to northern circuit. The feedback suitable for current amplifier is going to be the shunt series or current shunt feedback. The transconductance amplifiers are represented as Thevenin's equivalent circuit in its input side and northern circuit in its output side. Here, the input resistance is very large compared to the source resistance and the output resistance is very large compared to the load resistance. Hence, we have got the load current is going to be the transfer or mutual conductance with the product of the source voltage. Hence, the topology suitable for the feedback is going to be the series or current series feedback. In this transresistance amplifier, it is going to be the opposite version of transconductance amplifier. Here, the input side is represented as Norton's equivalent circuit and the output as Thevenin's equivalent circuit. Hence, the source resistance is going to be very large compared to the input resistance and the load resistance is going to be very large compared to the output resistance. Hence, the topology suitable for transresistance amplifier is going to be shunt or voltage shunt, and the output voltage is going to be the product of transfer or mutual resistance and the source current.